Students, welcome to you e-learning classes managed by Modern English School Nawal. Dear students, myself Vijay Kumar, your mathematics teacher, Modern English School, New Area Nawala. Today is the last video of the first chapter of the real numbers of class 10. Today I discuss of exercise 1D. So please see here, exercise 1D. First question is define rational number, irrational number and real number. First, what are rational number? A number in the form of p by q, where p and q are integer and q is not equal to 0. You write rational number in the form of p by q, where p and q are integer and q is not equal to 0. That is called rational number, like as 1 by 2, 3 by 4, minus 2 by 5, etc. are rational number. Next, irrational number. A number is neither terminating nor repeating and it cannot express in the form of p by q, and it has not perfect square root and cube root. That is called irrational number. So, one number is like at 1.01, 001, 0001. It is neither terminating and nor repeating, and it cannot express in the form of p by q. So, it is irrational number. And root 2 is equal to 1.414. It is not the perfect square root of 2. So, it is also an irrational number. And third, what are real number? Real number combination of rational and irrational are called real number. And a number whose square is always positive, it is also called real number. So, real number is the combination of rational and irrational. Then it is called real number. Now, second questions define it is rational, find out, classify that it is rational, irrational, etc. It is 22 by 7. It is in the form of p by q, so it is rational. It is 3.146. You can write this is like a 1000. So it is also rational number, 10,000. So it is also called rational number. Pi, it is irrational number because pi has not perfect value. You write pi is equal to 22 by 7, but it is not the correct value of the pi. So we can say pi is an irrational number. Here is 3.142857. We express this is 142857 by 9999. It is a rational number. It is a part of a rational. This is called terminating decimals and this is called repeating decimals. Both are rational. It is a rational. It is also rational. Next, 5.636363. That means it is equal to 5.63 rate. It is, you write 5.63 by 99. It is also a rational number. It is repeating decimals, but it is a rational number. This is 2.0400400004. We cannot express in the form of recurring and we cannot write in the form of p by q. So it is irrational number. We cannot write in the form of p by q, so it is irrational number. Similarly, 1.53, 5333, 5333, 5333, it is also an irrational number. We cannot write in the form of p by q. It is neither terminating nor repeating. It is not terminates and also not the repeating the same number. Here is 53, here is 533, here is 5333. So we cannot express in the form of p by q. So it is also an irrational number. Question that is 3 number and it is the question number 8 of 3. You have to prove this is an irrational number 2 minus 3 root 5. Dear student, you write solution. Let 2 minus 3 root 5 is a rational number. Rational number in the form of a by b. So we write 2 minus 3 root 5 is equal to a by b. Next step, you write 2 minus a by b is equal to 3 root 5. Here is minus, go that side, it is plus. Then here is b, it is 2b minus a. Here is 3 root 5. Next, 2b minus a by 3b is equal to root 5. It is rational number, but it is irrational number. So we write 2b minus a by 3b is a rational number, but root 5 is an irrational number. And both are equal. So we write 2b minus a by 3b is irrational and root 5 is irrational, and both are equal. It is not possible. You write it is not possible. Our supposition is wrong, hence it is contradict. So 2 minus 3 root 5 is an irrational number. Now, question number 5. Give an example of two irrational number whose sum is rational. And second example, give an example of two irrational number whose product is rational number. Dear student, this type of questions you can write in the form of conjugate, and then it is like as this: 2 plus root 3 is a rational number, and 2 minus root 3 is also rational number, irrational number. When you add them, what you get? You get 2 plus root 3 and plus 2 minus root 3. Cancel, then it is 4. So it is irrational, but sum is rational. So you can write this type of examples in the conjugate form. One is plus, another is minus. When you add it, then minus root 3 and plus root 3 will be cancelled. So now here is 4. So it is irrational, but their sum is rational. So one is this. This question you also use in the product also. So for second questions you can also write 2 plus root 3 into 2 minus root 3. Then it is in the form a plus b and a minus b, that is a square and minus b square. So it is equal to 4 minus 3, that is 1. Now students, here is irrational number, here is irrational, and their product is a rational. So your question is, give an example of two irrational whose sum is rational and two irrational whose product is irrational. So in both examples, in product and the sum, you can write only one examples, that is 2 plus root 3 and 2 minus root 3. Similarly, if you want to write other, then it is write 3 minus root 2 and 3 plus root 2. Other questions of the product, you can also write root 2 into root 8. Both are irrational, but product is root 16 and it is equal to 4, that is rational. So it is irrational, but product is root 16, that is rational. So dear students, you can write this type of examples, but I suggest you always write 2 plus root 3 and 2 minus root 3. Then you can use in the sum, also use in the product. Next question 11, that is 2 by root 7 is a rational number. You have to prove. You write solution and write let 2 by root 7 is a rational number in the form of a by b. So you write 2 by root 7 is equal to a by b. Next, slicing this, then 2 by root 7 multiply root 7 by root 7 is equal to a by b. So we write 2 root 7 by 7 is equal to a by b. Then what is the value of root 7? It is a by b. It is 7 and here is 2. So here is root 7 and it is equal to 7a by 2b. Dear students, now you can write it is contradict, because root 7 is an irrational number, but 7a by 2b is a rational number. Root 7 is an irrational number, but 7a by 2b is a rational number, so our supposition is wrong. Hence, we can write that 2 by root 7 is an irrational number because rational and irrational never equal to each other. So dear student, now you write root 7 is an irrational number, but 7 by 2 is a rational number. So our supposition is wrong. Hence, 2 by root 7 is an irrational number. Proof. Now see, this is the MCQ questions. A state equalist division's lemma. A state means you write the equalist division's lemma. You write A and B are positive integers. When A is divided by B, then we get Q is quotient and R is remainder. And so, by equalist division's lemma, A is equal to BQ plus R. So here R greater than equal to 0, less than B. Again one time. Let A and B are positive integers. When A is divided by B, we get Q is the quotient and R is the remainder. Then A is equal to BQ plus R, where R is greater than equal to 0, less than B. This is the called equalist division's lemma statements. So dear students, you write this. And also this type of statements given in your book of first page of the real number. Next, a state fundamental theorem of arithmetic. It is written in your NCERT book that any composite number, suppose it is 20, it is a composite number which has more than 2 factors, that is our composite. So 20 is a composite number. So state the fundamental theorem is that any composite number can express the product of primes and that is unique. Any composite number, suppose 20, then you can write 2 into 2 into 5. It is the product of primes. 2 into 2, 4 into 5, that is 20. It is the product of prime. Here is 24. It is also composite number. So it is 2 into 2 into 3. All are the primes, and when you product it, then it is 24. But all the factors are the prime. So it is called fundamental theorem of arithmetic. Any composite number can express as the product of primes, and that is unique. And question number 3, express 360 as the product of primes. Here is 360, it is also composite number. You write 180, again you write 2, it is 90, again write 2, it is 45, 3, 9, and this is 3 and 3. So 360 you can write 2 into 2 into 2 into 3 into 3 into 3. It is the product of prime because all numbers are prime, and when you do products, then you get 360. So this is the process. You can also say LCM method, but its original name is prime factorization method. So you express 360 as the product of prime, like as 2 into 2 into 2 and 3 into 3 into 3. Questions number 4. That is A and B are 2 prime numbers. Then what is the HCF? Dear student, prime number are 2, 3, 5, 7, 11, 13, etc. You find out what is the HCF of D. Then know any common factor other than 1 between common them. The factor of 2 is 1 and 2. Factor of 3 is 1, 3. Factor of 5, 1, 5. It is 1, 7. It is 1, 11. So common among them is only 1. So HCF is always 1. Then 2 prime number, then it is clear its HCF is always 1. Similarly, what is their LCM? Then the LCM is the product of prime. Suppose one number is 5 prime, another is 7. Their LCM is 1 because 1 is cancelled to both. But LCM is 35. So 35 is divisible by 5 and also 7. So LCM is the product of prime and HCF is the always 1. Then you are given that these number are prime, then HCF is 1 and LCM is the product of the prime, that is AB. If LCM, then your answer is AB. If HCF, then your answer is 1. Now 12 questions show that there is a no value of n for which 2n into 5n in with 5. Dear student, factor is 2 and 5. When you add, you get 10. That the last term is 0. it is clear any number whose factor is 2 and 5 both, then the int digit is always with 0. So we can write it is not possible that no any number at the place of n we write whose product is 5. Because when you write 1, then product is 10. When you write 2, then 2500. So you can say and you can write here that no any value of n when we put in the equations and we get 5. Because the product of 2 and 5 will always last digit is 0. Next, give an example of two irrational whose product is rational. Two irrational you can write one is root 2, another is root 8, and product is root 16, but it is 4. So it is irrational number, it is irrational, but it is rational. So we can say the product of 2 prime we get, it is a product of 2 irrational number, we get a rational number. Here is root 2, here is root 2. Similarly, you can write 2 plus root 3 and also 2 minus root 3. When you product, then you get 2 square minus root 3 square. That is 4 minus 3, that is 1. So example previous I also told you that you can take 2 plus root 3, it is also an irrational number, and 2 minus root 3 is also an irrational number. Last questions of this session is the LCM of two numbers is 1200 and so that HCF is 500, yes or no. So you divide 1200 by 500, then it is get 12 by 5. And dear student, you write here that it is not possible because every two number of LCM is always divisible by the HCF. But in these questions, the LCM is not divisible by HCF. So you can write the LCM is not divisible by HCF. So it is not the LCM and HCF of two numbers. So thank you students. Now remain questions of objective. We try to solve. If any problem, then ask to me my personal WhatsApp number. Thank you.